This is a demo video on the implementations that take place in the i-CNC use case. The use case is developed under the open call of the TrialsNet project by CNC Solutions, University of Patras LMS, and Focus Innovations and Services. The i-CNC use case belongs to the Industrial IoT with Cloudification category, as defined by ITU. The use case focuses on transforming the current CNC machining paradigm by addressing the chatter problem through an end-to-end solution that replaces traditional trial-and-error chatter supervision with a cloud-based and AI-enabled autonomous system. The setup of the i-CNC platform is as follows. A vibration sensor has been mounted on a CNC machine. A data acquisition system and a local processing unit collect the vibration signals. The signals digitalized and fragmented to network packets. The local processing unit feeds an operational assistant monitor, while at network level, it sends the produced packets to an industrial 5G router. Through a VPN connection and over a commercial 5G network, data are collected in a cloud infrastructure. The data are processed by an AI assessment unit, and the results are becoming available to the local processing system through an MQTT server. The setup is modular. Thus, data from multiple geographically distributed CNC machines can be collected. To illustrate this capability, data was collected from the primary site in Paeania and second site in Patras as well. After a series of tests and upgrades, a live demonstration of the i-CNC use case has been conducted during an open event in Paeania. During the event, the E2E system was used under real operating conditions at CNC Solutions. A monitor next to CNC machine was used as a virtual assistant to indicate chatter detection. The experiment conditions and the network performance were monitored as well. A live video connection was used to present the i-CNC system in site number 2, LMS Patras. Students, experts and CNC machine operators participated and provided valuable feedback. Indicative key performance indicators (KPIs) that were measured during the tests are 60 to 80 milliseconds round-trip delay at network layer, 140 to 190 milliseconds round-trip delay at application layer, as well as adequate user experience, given an unobservable time difference between the stimulus and the alert. All the data collected during the trials are open and available for further study. Find them in Zenodo. Thank you for watching.